All right, so now we're going to talk about proving triangles similar. So again, we talked about ratios, and then we used ratios and proportions to solve for missing measurements. We did the skittles. We found the number of missing skittles. Now what we're going to do is prove triangles similar. So it is going to be similar to proving triangles congruent. So remember when we proved triangles congruent, we had our shortcuts. So again, congruent is same size, same shape, and when we had our little like quote-unquote shortcuts, the ways we can prove triangles congruent with just 3 pieces, we have side, 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 angle, side, we had hypotenuse, leg, you can use angle, side, angle, or you can use angle, 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 side. Sorry, I said those backwards. Angle, angle, side, or angle, side, angle. So if you want to prove triangles congruent, these are the 3 pieces you need kind of in this specific order around your triangle. Now to prove triangles similar, it's almost the same. So similar figures have congruent angles. And remember, they have proportional sides. And again, proportional sides is going to mean, all right, so you remember, proportional means that they have the same ratio. Remember, a ratio is just a fraction. Okay, so now proving triangles similar. These triangles can be proven similar using, we have a side, side, side similarity postulate. You can have side, angle, side similarity postulate, and the other one is the angle, angle similarity postulate. So prove triangles similar, you only have these 3. So let's see, in angle, angle, if 2 angles of one triangle are congruent to 2 triangles of another triangle, then the triangles are similar by the angle-angle similarity postulate. And remember again, the symbol we use for similar is just the tilde. All right, so now let's see if we can use that similarity postulate. We're going to see determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. So let's see. Before you can determine if they're similar or not, you need to make sure your triangle has all the angle measurements. So this 26 is kind of going in there for C. So if we do 90 minus 26, that's going to give us 64 left for this angle. 90 minus 64 is 26. So all it takes to prove triangles similar are 2 congruent angles. Well, you have the 64s here, and then you also have, you actually have all 3, you only need 2, you have the 90s. So yes, the triangles are similar. All right, and it is by the angle-angle similarity postulate. And our similarity statement, remember like you see this guy up in the corner here, that's our similarity statement, similar to the congruent statement. So we're going to say triangle, I'm going to go HGK is similar to triangle. So if I go HGK, the angle that corresponds with this H is 64 degrees, so I want it to match up with the E. G is the 90, so D is the 90 in the other one, and then C. So that's your similarity statement. Example 2, show that the triangles are similar. Okay, so if we know they're similar, how do we know they're similar? It's by angle-angle similarity. So it is given to you that angle B is congruent to angle C, right? So angle B is congruent to angle C. That was given. Now, what is helpful if you have triangles like this that are overlapping is you need to redraw them separately. Because what happens is you have triangle here, and we're going to go AEB. And then we have another bigger triangle in this one. We have ACD. Well, if you notice in these triangles, they have an angle in common. They both share the letter A. So this angle A is actually congruent to itself. And what makes anything congruent to itself? That's because of the reflexive property. So yes, these 2 triangles are similar by the angle-angle similarity postulate. Not S, we need angle-angle similarity. Okay, what about in B? What do those triangles mean again? Oh, that's right. They mean parallel, not congruent. So you have parallel lines. Now, either of these lines can be your transversal. We're actually going to need both of them. If that's your transversal, there, you have alternate interior angles. So angle S is congruent to angle U, or U, because they're alternate interior angles. What else do you have? Look, these triangles are sharing a vertex. So remember, when triangles share a vertex, you have vertical angles. So angle SVR is congruent to angle, if we're going to go SVR, we're going to have to go UVT, and because those are vertical. And so then, again, we have enough because we have angle-angle similarity, because I've shown two angles are similar. All right, so for example 3, I would like you to complete this on your own. So are the triangles similar? So it's going to be a yes or no. If it's a yes, you're going to tell me why it's a yes. So go through here, A, B, and C, and then we'll check it when you get to class. All right, slide 3. Now, the next one we have is a side-side-side similarity. So if all the side lengths, corresponding, if all the corresponding side lengths of two triangles are proportionate, then the triangles are going to be similar by the side-side-side similarity theorem. So again, proportionate means they have the same ratio. You got to get that through your head. You got to get that whole like, oh my gosh, I'm scared of proportions out of there. Proportion means they have the same ratio. A ratio is just a fraction. You guys know how to build and make fractions. All right. Example 1. Prove triangles are similar. Is either triangle DEF, this one, or GHJ congruent to ABC. So it's like, okay, you have ABC. Which one of these other two is similar to ABC? Well, the way you figure out if triangles are similar, you have to see if the sides are proportionate. So we're going to set up, if they're proportionate, they have the same ratio. Ratios are fractions. So we're going to set up fractions. Remember, the smallest side is going to pair up with the smallest side. So I'm going to test these two first. So 8 over 8 reduces to 1. All right, the medium size is 12. This is the medium size here. So I'm going to do 12 over 10. That's going to reduce to 6/5. So right away here, you have two ratios that are not the same. So there's no way that those triangles are going to be proportionate. So this one's out of there. Let's try the other one. So we have, here's the small side in 8, and here's the small side in 6. So 8 over 6 is going to reduce to 4/3. Let's see, medium 12 over 9 reduces to 4/3. And then we have 16 over 12. Take a 4 out of both, 4/3. So you can see there, this is what I'm talking about. If they're proportionate, they're going to have the same ratio. And all we did to find this ratio was we set up the pieces on top of one another like a fraction. So this is it. This is the triangle that is similar to triangle ABC. So example 2, find the value of x that makes the triangle similar. So remember again, if they're similar, they're proportionate. What kind of equation have we used that has kind of the word proportionate in it? It's a proportion. So this whole unit is all about proportions and ratios. So if you're trying to find the value of x, remember we have been harping on you when we did the Skittles. To find missing Skittles, pieces, measurements, sides, angles, you can, if things are similar, you can use a proportion. So we're going to make our proportion. We're going to pick some corresponding pieces. All right, well, we have a bunch. It doesn't matter which ones you pick. We can see here that AB corresponds to DE. So I'm going to build that as 4 over 12. Now, it doesn't matter if you picked another side. We couldn't pick any other sides because we have some constants here. These are the only constants we have. If you did 12 over 4, that's fine. All right? This order only matters when they give you a specific order. Now, this is, on top is the small triangle. So we went small over large. We must go small over large on the other side. So we need to solve for x. Well, here's x minus 1. That's with the small triangle. That pairs up with the 18. Cross multiply. So 12x minus 12 is equal to, cross multiply, 18 times 4. How much is that? Hold on. Let me bust it out. 18 times 4, 72. We have to add 72 to each, so 12 to each side. So 12x is equal to 84. 84 divided by 12 is 7. So your x is 7. And you don't have to find this. I mean, once you solve for x, you've solved for x because everything is proportionate. So that is not going to change a thing. On to the next. All right, so side-angle-side similarity theorem is a kind of a combination of the angle-angle similarity and the side-side-side similarity. So what you're going to look for is you need an included angle. So if one included angle, so remember, that's super important. We talked about that last in the congruent. Included means in between. If an included angle of one triangle is congruent to an included angle of a second triangle and the side lengths are proportionate, then the triangles are similar by the side-angle-side similarity theorem. So you can see kind of over here in the diagram. They told you that xz, right, is equal to pm. So this means that this ratio of these two sides is equal to the ratio of these two sides. So they're proportionate. It's a proportion. Side, angle, side. So the sides are proportionate, the angles are congruent. So, example 3. Prove the triangles are similar by the side, angle, side. Okay, so are they similar by side, angle, side? Well, the first thing you're going to look for is there an included angle? So we have a side. Yes, that 53 is in between. Is the 53 in the same exact spot on the other triangle? Yes, so make sure that both triangles have the included angle. Now we have to see if the sides are proportionate. So 6 is the smaller one, 9 is the smaller one. So I'm going to go 6 over 9, reduce that to 2/3. We got to check the other one. So 10 pairs up with a 15. If you take a 5 out of both, 2/3. So yes, by the side, angle, side, similarity postulate, because you have sides are proportionate. Right here, proportionate, same ratio. Ratio is just a fraction. Bam. The angle's included. All right. Example 4. Choose a method. Is it angle-angle similarity, side-side-side similarity, or side-angle-side similarity? Explain how to show that the indicated triangles are similar. All right. Well, I see we have an angle marked here. Is it included in between the two sides? Yes. All right. Let's see. This is 18. I'm going to pair it up with this one, 24. Because those are both the short ones. If I take a 3 out of both, what can we take out of both? 18 divided by 24, math, enter. So we get 3/4. We got to check, though, to see if that other pair of sides is the proportionate. So 21 over 28, we take a 7 out of both, we get 3/4. So since they have the same ratio, they are proportionate, the angle is included, so we have side-angle-side similarity. All right, our XZW, this one, is it similar to YZX? All right, well, we have some angles here. So we got to see if the sides are proportionate. So remember, sometimes you could have two different ways triangles are similar. I'm going to say, all right, this 9 actually pairs up with the 12 because they're both the smallest pieces of the triangle. Take a 3 out of both, you get 3/4. The 15 pairs up with the 16 because they're, oh, did I do that right? Sorry, the 15 is the long one. Oops, let's go back. All right, so the 9 pairs up with the 12. Then the medium, if you're looking at this triangle over here, the medium leg is the 12. It's going to pair up with the 16. So 12 over 16. Now the way you build your ratio, when you start your ratios, it doesn't matter. I went the small triangle over the big triangle. So you have to mimic it each time you do your ratio in order to see if they're proportionate. So if you take a 4 out of both of these, you get 3/4. Now the next piece, we have this 15 is the longest side. It's also the hypotenuse. It's going to match up with this hypotenuse. So 15 out of 20, if you take a 5 out of both, you get 3/4. So these guys are similar by side, side, side similarity. You could also say side-angle-side similarity because you have that 90-degree angle sandwiched in between. So either one will work, side-angle-side or side-side-side.